Okay, now we're going to deal with probably the most useful of all the ones, the most versatile, because you can use it pretty much in any situation. It is the ideal gas law. The ideal gas law is PV equals nRT, and that would be P is pressure, V is volume, N is the number of moles of the substance, R is a constant, and if it were talking in ATM, as far as pressure, R is 0.082, you see right down there. 0.082 is R, and T is temperature in Kelvin. So this one will work pretty much the same way as any of these laws on your right here, but it's a little more versatile. It's a little more complicated, but it'll also work in more situations. So this one, anytime you're given a certain grams of a substance, you're probably going to want to use the ideal gas law. If you're ever given the grams of a substance, you're probably going to want to use the ideal gas law. So let's go and do an example of this. So let's say I have 25 grams of oxygen in a 5-liter container. And I want to know what the pressure is going to be. Well, I need one more set of information. Let's say it's at 25 degrees Celsius. So it's at 25 degrees Celsius. I have 25 grams of oxygen in a 5-liter container at 25 degrees Celsius. What will the pressure be? So if I had 25 grams of oxygen in a 5-liter container at 25 degrees Celsius, what would the pressure be? Well, that's when I'd use my PV equals nRT. Our P, which is what we'd start with. But our P is our unknown right now, so we're just going to write it in as P. Our volume, we see right up here, we have our volume in liters, which is what we want. We're going to write it in, and we're going to put 5. It is equal to N. N is the number of moles of a substance. So we'd actually have to figure out how many moles of O2 we have. We have 25 grams of O2, and if we convert that to moles, we divide it by its molar mass. So we'd do 25 divided by its molar mass, which is 32, and that gives us 0.71 moles. So we'd say 0.781 moles. And then we're going to times that by our R. R is a constant that's based on what kind of pressure you use. And we want this in ATM, so our R is going to be 0.082. That'll be something that's given to you. It's constant, so it's always going to be 0.082 if you're solving for ATM. And then the temperature. We know it's 25 degrees Celsius, but we need it in Kelvin, so we're going to add 273 to it. So it's going to be 298. So we're going to write in 298. So now we have our liters. We have our liters, our moles, our R, and our temperature. We just want to solve for this P right here. Now, how would we solve for that P in algebra? Well, we want to get P by itself, so we would divide by 5. That gets rid of the 5. Then we have to do the same thing to this side. We're going to divide by 5. So I'll do 0.781 times 0.082 times 298 divided by 5, and that should give me my pressure. And the pressure that I get is 3.81. 3.81, and since we use a 0.082, that's the ATM constant, so it's going to be 3.81 ATM is our final pressure in that situation. That's a quick overview of how you do the ideal gas law. If you need more help, please come talk to me. I know it wasn't comprehensive, but it was hopefully a quick refresher if you needed help with that.